All right, girls, I'm going to get started. We know the area of a triangle is half times a rectangle because you can get two triangles out of a rectangle, as you can see. Yep? Yes. Now, we're going to explore area of special quadrilaterals. So, first of all, what's a quadrilateral? Four-sided shape, yep. So, we're going to look at these special quadrilaterals. So, right now we have a rectangle, yep. And if we have a rectangle, what do we do with the base and the height to find the area? So, for example, if I had 10 and 6 centimeters, yeah, so you just do 10 times 6 to find the area of a rectangle, yeah? Now, have a look at this. Back to base and height. What shape is this now? Parallelogram. So can you see that the area of a parallelogram is exactly the same as a rectangle, but the shape's just been manipulated? So what did you do with the base and the height in the beginning to find the area of a rectangle? Times it. So same thing applies to parallelogram. Okay, you just multiply the base and the height. So for example, if you've got 10 and 6 centimeters, you just times them to find the area. Yeah. But just make sure the height, it's got to be the perpendicular height, which I'll explain later on. Yep, so that's that. Now, area of a kite. So let's say the length of the diagonal inside the kite is x for now. Yep. And let's say the other diagonal length is y. Okay. Now, what I'm going to do is get this part of the kite. I'm going to flip it like that, and I'm going to move it to the top like that. Okay. I'm going to do the same thing with that one. Flip it around, and I'm going to move it to the top. What shape is this now? Rectangle. Now, as we know, with a rectangle, we just multiply the length and the width, or base and the height, yeah? Now, my base in this case is x. What do you think that length is if our original length was y? If that whole thing was y, what do you think that is? That's right, half of y. And what do we do with those two to find the area of, in this case? That's right. So the area of a kite is half xy because you're multiplying those two lengths like a rectangle. So basically everything's like a rectangle, it's just been manipulated. Okay? So for example, if I'm given the diagonal lengths like that, all you have to do is just do half times the diagonal lengths. Yep? In this case, that's 30 square meters. Now, rhombus. Now, what distinguishes rhombus from a kite is, I didn't label it here, but with a rhombus, all sides are equal. So it's like 5 centimeters, 5 centimeters. Right? So all sides are equal in length with a rhombus. So I'm going to do the same thing. Let's call that diagonal length x, and let's call that diagonal length y. What I'm going to do is I'm going to get that, move it to the top. Oh, sorry, I went a bit too fast. Get that one as well, and I'm going to move both of them to the top. Can you see what I did? Yeah, it's a rectangle once again. So if that's x, what's that? Half y. Yeah, let me just go back. That whole thing was y? So half of that would be half y. And once again, it's a rectangle. So the area for a rhombus is also half xy. So it's the same formula for kite and rhombus. Okay? So for example, once again, if I give you the diagonal lengths like that for a rhombus, all you need to do is just do half times 9 times 7. So that's 31.5. Okay? So that's the reason for the formulas of special quadrilaterals. Now with trapezium, it's a bit more complicated, but I will show you later. Okay? So for now, I'm going to show you how to apply these formulas now that we know the reasons for these formulas. Okay, so find the area of this. Sometimes they'll trick you. This is obviously a parallelogram. Okay? The area formula, as we know, is base times height. What's my base in this case? What's that length? It's not given, but it's the same as that. Yep? I'm not going to write the formula because it's already there. 10 times. Now, what's the height?
5.
It's 5. It's not the 7. That's there to trick you. The height is always the one attached to the right angle, okay? Just like a triangle, like I explained yesterday. So make sure you times the right height. So that's 50 square meters, okay? Sometimes they'll give you the question rotated like that. It's still a parallelogram. What's my base? Base is always going to be, yeah, usually the longest length of the parallelogram. But what's my perpendicular height? What's the height? Yeah, it's 3. It's always the number attached to the right angle. Even if that 6 is attached to the parallelogram, that's a slanted height. We don't want that. It's always the one attached to the right angle, okay? So don't be confused. Even if it's not part of it, what this is saying is if it's 3 there, it's also 3 like if it was inside as well. Does that make sense? Yeah, which still makes a right angle. So sometimes they'll give the height outside, not inside, just to trick you like that. So that's 24 square meters. All right? All right, now, area of a trapezium, what you need to do is take half the height, and once again, it's perpendicular height, and you have to multiply it with the sum of the top and the bottom lengths, which are parallel to each other. which I'll explain why that's the formula in a minute, but let's just learn how to apply it first. So what you do, you get the height. What's my height in this case? 8. You get the 8, always put it over 2, bracket, these two added up together, 7 plus 17. Doesn't matter which order you write it, as long as they're added in the bracket. Put that in the calculator and that's basically your answer. 6, okay? So that's 96 square meters. Okay, so that's how you find the area of a trapezium. Now, with a kite, I've shown you an example, but sometimes they like to be tricky and not give you everything that you need to actually find the area of a trapezium, kite. So we know it's half times the diagonal lengths, yeah? But in this case, we're not given the full diagonal length. It's always the full diagonal length we need. So we need that whole thing, but right now we're only given part of it. They're saying it's only 60 up until here to here, and we aren't given the whole second diagonal length. Well, let's calculate it. We're given this little dash, meaning it's 30 here, 30 there, 30 there as well. So if it's 60 up until here, yeah, that bit is 30. Oops. So the whole thing is 30 plus 60, which is 90. So that's half times 90 times, now with this one, it's 30 plus another 30,
60.
Which is 60 because they've got the same dashes. Yep. So that's what you want to do before you apply the formula. Okay. And in this case, it's square centimeters. Okay. So make sure you get the full diagonal lengths. Same applies for a rhombus. Sometimes what they'll do is they'll give you like half of it. One little fact about rhombus though, the diagonal lengths are always equal to each other. Okay. This is equal to that. This is not, okay, this is not equal to that, but it is like bisected in half. Yep. So sometimes, so for example, if they give you, let's say that's 5, and let's call that, let's say that's, I don't know, is that actually longer? 3. Yep. So then the whole diagonal length would be, what's 5 plus 5? Yeah, so we would do half times 10 times, what's this whole thing? 6. Okay, should have been the other way around. This is the longer diagonal, but you get my point. Yep, so sometimes they'll give it to you like that. So don't just plug in the numbers and expect to get the answer, right? It's always a full diagonal length like I've shown you here. Okay,